This is Review 1, How to Factor. First we have to know that our A value is 1, our B value is 7, and our C value is 10. From this, we draw an X. On the top goes a 10, on the bottom goes a 7. We want to find two numbers that multiply to give us 10, like 5 times 2, and two numbers that add to give us 7. So these two numbers we write here, and we write in factored form like this. Let's try this again. 18 on top, negative 11 on bottom. So if I look at negative 9 times negative 2 and negative 9 plus negative 2, those are the two answers that fit this math riddle. I write my answer like this, and I'm good to go. Another one to solve by factoring, we'll add 11x and we'll put it over here just for safekeeping. And minus 7 like this. So we have x squared plus 11x, because we're combining like terms, plus 18 equals 0. These cancel out, and this one just drops down in the correct standard form order. So if I think about 18 and 11, that's 9 and 2. So my factors would be something like x plus 9 and x plus 2. But that's not what they ask for. They ask for the solutions, which are going to be negative 9 or negative 2. If you go into a calculator and take the square root of 100, the answer is just 10. Another answer to this is negative 10. We can write this like this, plus or minus 10. Root 45 is not a perfect square, but you can turn this into this. So out of the list of perfect square factors, what you want to do is you want to think about what's the largest one that is possible to go into 45. So we start here. And we do 45 divided by 36, decimal. 45 divided by 25. 45 divided by 16. 45 divided by 9, and that's the first whole number. So it splits like this. That's where the 5 comes from. That's 45 divided by 9. Then we can simplify the root 9, because that's on the list of perfect squares. It turns into a whole number. And we'll leave our answer like this. Similar process, this turns into root 49 times root 2, or 7 root 2. And optionally, you can put the plus or minus there to indicate that it could be positive or negative. Since 36 is a perfect square, the answer is just plus or minus 6. You could do that one on your calculator. For this one, because our A value is bigger than 1, we have to use a different method called the slide and divide. So we slide over the 2, we have x squared plus 15x plus 56. So when I do the x method, I have 56 on top and 15 on bottom. The riddle is 8 and 7. So I write this like this. And now I divide by my original A value, which is 2. And this part just turns into x plus 4. And this part would be a decimal, so I can slide this over here like this, 2x plus 7. And those are my factors. Slide and divide, I slide the 5 over here, so I have x squared plus 21x plus 20. This means 20 on top, 21 on bottom, so the factors are 20 and 1. X plus 20 times x plus 1, and I divide by the 5 from the original. So this first factor is x plus 4, and the second factor is 5x plus 1. To avoid the decimal, I just scoot the 5 right there. Next up, I want this to equal 0, so I do minus 7x and plus 9. I line these up to combine like terms wherever possible. There is no x term, so that's why I just wrote it off to the side. When I drop all this down, I want to write it in a specific order. I'm following that model of ax squared plus bx plus c, so that's why I put the x squared first, then the x. Here, I'm going to do the slide and divide first. So this becomes x squared minus 7x minus 8. Minus 8 goes on top, minus 7 goes on bottom. So this is going to be negative 8 and positive 1. So I could write it like this. And if I start to do the rest of the slide and divide, I'm going to divide by 2 on both sides. And I could stop here and jump straight to the solutions, which are the opposite of these values. So if this is x minus 8 over 2, that's x minus 4. So the opposite would be positive 4. And this one is plus 1/2, so the opposite of that is minus 1/2. Alternately, I could, of course, jump to here and look at it like this. It's a little bit harder to figure that out, though. I'd have to set it equal to 0 and solve. It's probably easier just to go from here and take the opposite. Both will get you there. Here's another one, minus 7x on both sides, plus 9 on both sides. 3x squared minus 4x minus 7 is equal to 0. Then I'm going to do the slide and divide, so I have x squared minus 4x minus 21. Minus 21 on top, minus 4 on bottom, so let's do negative 7 and positive 3. I'm going to divide by my original a value, which is 3. So for this first one, I'll write 3x minus 7, and for the second one, I'll write x plus 1. Now it said solve, so actually these would be my factors, factored form, but I want solutions. This first one is going to be 7/3, the second one will be negative 1. I just take this and I take the opposite. I take this and I take the opposite. You can skip the factored form entirely if you like. This is called difference of squares. I take the square root of this and the square root of that and I plug it into a specific formula. That is, it's for sure going to look like this, where there's a plus and a minus. And this becomes 6x on both of these, and this becomes 1. That's the square root of this part goes here and there, and the square root of that part goes there and there, and it's always plus minus. Let's try another one. I know that I'm going to have the two sets of parentheses with a plus and a minus. The square root of all this is 11x. The square root of this part is 7. When I try the same thing here, the only difference is that whenever I have an exponent like 4, I just cut it in half of its original value when I take the square root. So this is 5x squared y, 5x squared y, and this is 1 and 1. Same thing here, plus, minus, 9 and 9 for the first one. And this is x squared y cubed, x squared y cubed, because I cut those both in half. Flying through, here's review number 2, parabolas. Coordinates of zeros are here and here. That's 2, 0, and 4, 0. Zeros are here and here. That's negative 5, 0, and 1, 0. X-intercepts are actually the same thing. Negative 8, 0, and negative 2, 0. 6, 0, 8, 0. We can call these x-intercepts, we can call them zeros, we can call them roots, we can call them solutions. Axis of symmetry is the vertical line that passes through the vertex. It's always going to be x equals the x-coordinate of the vertex. So here x equals negative 3. And down here it's going to be the vertical line that passes through the vertex. X equals 1. A couple different ways to graph this. Probably going to use a calculator. Since I don't really have one, let's think about it like this. 35 and 12. That'll give me 7 and 5. So if I think about x plus 7 and x plus 5, my two zeros will be there and there. My vertex is going to be at negative b over 2a. So that'll be at negative 24 over 2. Oops, sorry, I don't know why I said 24. That's negative 12 over 2, or negative 6. And if I plug in a negative 6, I think I'm going to get, what is that, a negative 1? So it's going to look something like this. 2 more points here are going to be negative 4, 3, and negative 8, 3. So as long as I have 5 and I've sketched it and I have both of the roots and the vertex, these are the roots and this one is the vertex. Trace does a great job. Remember to press zoom 6 on the calculator. From here, axis of symmetry is x equals negative 2. Vertex for this one is at 7, 1. My zeros are at 6 and at 8. One other point is at 5. Is it 5, negative 3? Yes. So then 9, negative 3, like this. Cruising right along here with review number 3. For my a values, remember the positive ones go up and the negative ones go down. So I can match those. I also know that the wider ones are the decimals. So this is negative 0.25. And this one is negative 1 and this one is positive 1. All three of these are negative. So this is the wide, this is the narrow, which means this is negative 4, and this is negative 0.25, and this one's just negative 1. If you want to use the algebraic formula, use this, which means negative 2 divided by 2 times 1, or just x equals negative 1. That's the axis of symmetry. This one is negative 28 divided by 2 times 2, or x equals negative 7. This one we can start similarly. If we do negative b over 2a, we get negative 24 divided by 2 times negative 4. So this gives us 3, and that's the x-coordinate. If we want to find the y, we can do negative 4 times 3 squared plus 24 times 3 minus 40. And just plug that into our calculator. Looks like I'm going to get negative 52 for my y value. I would start off by doing negative 40 divided by 2 times negative 5, which is just going to give me 4. If I plug that in, like this, I can find my y-coordinate, and that's going to give me 10. So the answer is 4, 10. Oh, sorry about that previous one. I just noticed my mistake. That is actually, I forgot when I did it in the calculator, I left off the x here, so that's where I went wrong. And this is actually 3, negative 4. So yeah, when I put in the calculator, I forgot the x. This is the correct answer. To match the graph here, we're going to look at things like the y-intercept, which is negative 9. So it's either this one or this one. It's not b or c. And then because it opens down, we know that the a value has to be negative, so we're going to pick D. Number 8 has a y-intercept of around here, which is 4, so it's not these. And it opens down, so we're going to pick A. For this one, we look at 5 and 7, which means we have x minus 5 and x minus 7. So I'm going to cross off these two. And it opens up, so we want a positive a value, which exists right here. I'm going to look at this one and this one, which means I have x plus 7 and x plus 3. So that looks like A or D, and then it opens up, so I have choice A. This one's about the vertex. This is at negative 6, 1. So I can write this as x plus 6 squared plus 1. You'll notice that the x-coordinate is opposite, and the y-coordinate is not opposite. So that rules out these two, and rules out this one, and then my a value is negative, so C is correct. Over here with number 12, my vertex is negative 5, 1, which means I'll have x plus 5 squared plus 1. So it's either going to be B or C. This is the one that has the positive a value, so it's B. This one, they just want to identify A, B, and C. The trick here is that they're not in order necessarily. A is in front of the x squared, B is in front of the x, and C is the constant. So here it's 3, negative 3, and 5. Here A is negative 8, B is 0, because there is no x term, and C is negative 1. To solve this one, I need to get this part by itself, so I start with the part that's farthest away, and I can rewrite the rest, and then I divide by this, and then I add 4. I have x squared is equal to 4. At this point, I'm going to take the square root of both sides. I have x is equal to plus or minus 2. Those are the two answers. For number 4, I'm going to first subtract 7 from both sides. I have 5 times x squared minus 10 is equal to negative 5. Then I'm going to divide both sides by 5. I have x squared minus 10 is equal to negative 1. Then I'll add 10 to both sides. So I have x squared is equal to 9. Once I take the square root of both sides, I have x equals plus or minus 3. First, I will subtract 2 from both sides. I am left with negative 3x squared is equal to negative 27. Then I'll divide both sides by negative 3. So I have x squared is equal to 9. This is just like the previous one now. And it looks like that. The formula for discriminant is b squared minus 4ac. So I have to recognize what a, b, and c are, and they just go like this, and then I plug them into the formula. So I have 2 squared minus 4 times negative 3 times negative 7. You can just plug this directly into a calculator, and I believe you get negative 80. For this next one, it's b squared minus 4 times a times c. So this is 25 minus 12, which is just 13. No multiple choice. Similar process, 2 squared minus 4 times negative 3 times 53. I type that into Google and it tells me 640. This one's not equal to 0, so I have to do this step first. And then I can rewrite things a little bit, and this is negative 5x squared minus 4x plus 45 is equal to 0. I'll cross these out just so I don't get confused. So I have negative 4 squared minus 4 times negative 5 times 45. When I type this in, I get 916. For number 10, let's add 7x to both sides. Let's minus 2 from both sides. I have negative x squared plus 18x plus 81 is equal to 0. That's 18 squared minus 4 times negative 1 times 81. This answer is 648. So the key for these next ones is if you get 0, it's the top one. If you get a perfect square, it's the next one. If you get something that's not a perfect square, it's this one. And then the last one is if you get a negative value. So we're still going to take negative b squared, or just b squared, excuse me, it's negative 20, minus 4 times a times c. If I do this, I get negative 288, which means the answer is D. 8 squared minus 4 times negative 2 times 90. This gives me 784. To do the test, I want to figure out, is this a perfect square? And the answer to that is, let's type it in, square root of 784 is 28, which means it's B because it's a perfect square. 16 squared minus 4 times negative 1 times negative 15. If you do this one, you get 196. If you take the square root of that, you get 14. So again, it's going to be B. Last one of this type, 40 squared minus 4 times 64. I get 576 if I take the square root of that. I get 24. So the answer again is B. If I got a decimal there, it would have been C, but it's a perfect square again. Next up, 11 squared minus 4 times 1 times 16 tells you the discriminant. That turns out to be 57, which is not a perfect square and not anything that I can round. So this is just my final answer. Negative b plus or minus the square root of the discriminant. Sorry, almost forgot the square root there. All over 2 times a. Next up, I have negative 10 squared minus 4 times 3. If I take this, I get 52. So if I want to simplify the square root of 52, I can turn this into root 4, root 13, which turns into 2 root 13. So this is going to be 10 plus or minus 2 root 13 all over 8. And I can divide everything by 2, those parts by 2 at least, to get 5 plus or minus the square root of 13 all over 4. And that's my final answer. Next up, I have 1 squared minus 4 times 2 times negative 1. This will give me a discriminant of 9. So I have negative 1 plus 3 over 4. I have negative 1 minus 3 over 4. So this part will simplify to just 1/2. And this part will simplify to negative 1. Those are my two answers. Here I have to add 10x to both sides first, so watch out for that. Now I have x squared minus 5x plus 5 is equal to 0. I'll just cross that part out. And I'm going to do negative 5 squared minus 4 times 1 times 5 to see my discriminant. This will give me 5. So I'm going to have 5 plus root 5 over 2, or 5 minus root 5 over 2. If I add it, I get 3.6. If I subtract it, I get 1.4. This would have been like a 1.38, which is why I round up to 1.4. I have to subtract 1 from both sides, so I have 3w squared plus 15w plus 17 is equal to 0. 15 squared minus 4 times 3 times 17. The discriminant here is going to be 21, which means I'll have negative 15 plus or minus the square root of 21 all over 6. Can't simplify, leave my answer like this. Last one, let's add 5p squared to both sides. So I have p squared plus 8p plus 3 equals 0. I'll just cross this part out so I don't mess up. 8 squared minus 4 times 1 times 3. So this is 64 minus 12, which is going to again give me 52. I wish it was a different one, but here we are with the same one. You can split it into the perfect square factor of 4 and 13. So this turns into 2 root 13. So this is negative 8 plus or minus 2 root 13 all over 2. If I divide everything by 2, nice thing happens here. This turns into negative 4 plus or minus root 13. Here's my final answer.